You're welcome back to ID International Academy online class. How was the last contact? Did you enjoy it? I'm sure you are going to enjoy today's contact as well. Before we go to today's work, let's have the solution to the previous assignment. In the assignment, this is number 1 question. Simplify 4 over p minus 3 minus 1 over p plus 2. Simplify the LCM of the denominators here, which is p minus 3 into p plus 2. LCM of something like this is the product of the two of them. And at times, if they are element of difference of two square, it may not be the product of the two of them, it may be just one of them that will represent the LCM. But in this case, product of these two is the LCM. So p minus 3 and p minus 3 into p plus 2 will give you p plus 2. What do we mean? P minus 3 as the LCM plus p minus 3 into p plus 2 is the LCM. Now, p minus 3, use it to divide this. P minus 3. What do we have left? When you cancel this, you have p plus 2 left. It is that p plus 2 you have left you will use to multiply the numerator of it, which is 4. So you have 4 into p plus 2 minus. Now use p plus 2 to divide this LCM. It will now be like using p plus 2 to divide this. So this will divide this. This will cut this. You will have p minus 3 left. The p minus 3, use it to multiply this 1. You have 1 into p minus 3. Opening the brackets, in each case, you have 4p plus 8. Minus 1 times p is minus p. Minus 1 times minus 3 gives you plus 3 all over p minus 3 into p plus 2. 4p minus p gives 3p plus 8 plus 3 gives plus 11 all over p minus 3 into p plus 2. And that is the end of that. So let's move straight to question 2 in the assignment. Question 2 in the assignment. Write 2 minus y over y plus 2m as a single fraction. How do you write as a single fraction? Simplify, so to say. You know that here the denominator of these two is 1, invisible. So you want to find the LCM of 1 and this algebraic expression. Definitely the algebraic expression is the LCM in this case. The LCM between y plus 2m and 1 is y plus 2m. So the 1, which is the denominator of 2, use it to divide y plus 2m. It gives you y plus 2m back. So use that one, y plus 2m, to multiply the numerator 2. You have 2 into y plus 2m. Now minus. Use y plus 2m to divide y plus 2m, the LCM. It gives you 1. That 1, use it to multiply y. So opening this bracket will be 2y plus 4m minus y all over y plus 2m. Are you following? 2y minus y gives y plus 4m all over y plus 2m. That is the simplified term of this fraction. We have written it as a single fraction in its simplified term. So that is it. Let's go to question 3 in the assignment. The value of 2 over x squared minus 1 plus 1 over x plus 1 when x equals -1. Don't just, I think I've told you this before, don't just straight away substitute the value of x given to you into the expression straight like that, it will be funny. You won't get the correct answer. Simplify the expression first before you substitute for the value of x. So, in simplifying this, find the LCM of the denominators. This is what I explained to you the other time. These denominators are they are components of difference of two square. X plus 1, x square minus 1. X square minus 1 is a difference of two square, which means x minus 1 into x plus 1. That is x square minus 1 that can give us this. You know that. So, x square minus 1, use it to divide this LCM. It gives you 1. Because you know x square minus 1 means this. And when you use it to divide itself, it gives you 1. So 1 times 2, you get 2. Plus. Use x plus 1 to divide this LCM. So x plus 1, we cancel x plus 1, you will have x minus 1 left. That x minus 1 left, use it to multiply 1. You have 1 into x minus 1. So you will have 2 plus x minus 1. When you open this bracket, 1 times x is x. 1 times minus 1 is minus 1. All over x minus 1 into x plus 1. Simplify the numerator further. 2 minus 1 gives you 1, which is x plus 1. And when you have to add 1 to x, it's the same thing as x plus 1. All over x minus 1 into x plus 1. You can see that x plus 1 can cut x plus 1 here. How many times do you have x plus 1 in x plus 1? It's 1 time. Write it down. That is to say, when you use x plus 1 to divide this x plus 1, it gives you 1. Now use the same x plus 1 to divide x minus 1 into x plus 1. It will give you x minus 1. This will cancel this. While you have x minus 1 left at the denominator level, you have 1. Though it seems invisible before, you have 1 left at the numerator level, and which is this. Now substitute x equal to minus 1 into it. That is 1 over minus 1 minus 1. Wherever you see x, put minus 1 there. So in this case, this is minus 1 over 2. That's the answer. If p equals this, express p minus 1 over 2p plus 1 in terms of y. So bring p minus 1 over 2p plus 1 here. You want to rewrite it in terms of y. How? Wherever you see p, bring the value of p to substitute here. P is 2y plus 3 over 3y minus 2. That is p, as we can see here, minus 1 divided by 2 into, what is p? 2y plus 3 over 3y minus 2 plus 1. So, find the LCM of the fraction in the numerator. So you have, the LCM there is 3y minus 2. Don't forget, we are dealing with what is up there, the fraction at the numerator part. So the LCM is 3y minus 2. 3y minus 2 in 3y minus 2, it gives 1. 1 times 2y plus 3, it gives us 2y plus 3 minus. Look at this 1. It has its own denominator, which is 1. That 1 is in 3y minus 2, it gives 3y minus 2. 3y minus 2 times the 1, you write 1 into 3y minus 2. Instead of drawing the division line again, you can come to the side of it, use it as division symbol, and open this bracket. You have 4y plus 6 over 3y minus 2 plus 1. Take note of what happens here. Whenever you have to multiply a fraction by an whole number, that whole number will multiply only the numerator of the fraction. Don't forget, that whole number will multiply only the numerator of the fraction. That is why this 2 multiplies only 2y plus 3. It's like I used to open 2y plus 3. So it multiplies 2y to give 4y, but it multiplies plus 3 to give plus 6. It does not affect the denominator. That is how we use it. So, simplify each part. 2y plus 3. Open this bracket. You have minus 3y plus 2. Minus 1 times minus 2 is positive 2. Minus 1 times 3y is minus 3y. All over 3y minus 2. Divided by the LCM of this will be 3y minus 2. Because it's the LCM of 3y minus 2 and 1, the denominator of this one. There is an invisible 1 under this 1. So, 3y minus 2 in 3y minus 2 gives 1. 1 times 4y plus 6, you have 4y plus 6 plus the invisible 1, which is the denominator of this 1. Use it to divide 3y minus 2. You get 3y minus 2 as your result. That 3y minus 2, use it to multiply the 1. You have 1 into 3y minus 2. Simplify this. 3y minus 3y gives you negative y. So you have 5. 3 plus 2. 5 minus y over 3y minus 2. Divided by, open this bracket with 1. Plus 1 times 3y, you have plus 3y. Plus 1 times minus 2, you have minus 2. All over 3y minus 2. Continue on this side. We have 5 minus y all over 3y minus 2 divided by 4y plus 3y, that is 7y, plus 6 minus 2, that is plus 4. I hope you are following. Divided by 3y minus 2. Wherever you see the division operation, it turns to multiplication. So you have 5 minus y over 3y minus 2 times. When you change the division operation to multiplication, the divisor will turn upside down, because multiplication is the inverse of division. So you will inverse it. So you will write 3y minus 2 all over 7y plus 4. So you can see that this will cancel this. You can see? Can you see? So you will have in the numerator part 5 minus y left all over. In the denominator part you have 7y plus 4. And that is the end of the solution to the assignment. We can now move on to today's work. So today we are dealing with quadratic equation. You know, we've been dealing with something quadratic all the while. But now we are dealing with the equation. We've been dealing with quadratic expression of different forms. But now no longer expression but equation. What is quadratic equation? It is quadratic because it has degree 2. When the highest power of the variable is 2, the highest power of the variable in the something, when it is 2, we call it quadratic. Because it includes equal sign, that makes it equation. So we are now talking about quadratic equation. So quadratic equation is any equation in which the highest power of the variable is 2. Example 1. Find the roots of x squared minus 2x equals 0. When you hear about quadratic equation, something should come to your mind. Ask me what? That is the roots. What we are particular about in quadratic equation is the roots of the equation. The roots of the equation. What do we refer to as the roots of the equation? The two answers we get in quadratic equation are called roots of the equation. Mind you, we get 2 answers in any quadratic equation. And the same thing applies to quadratic expression. In quadratic expression, we have 2 factors. You can see we factorize quadratic expression into 2 factors. This into this into that. Also in quadratic equation, we have 2 answers. Those 2 answers are what we call roots of the equation. So example 1, find the root of x squared minus 2x equals 0. X squared minus 2x equals 0. When you have a binomial quadratic equation like this, you apply the simple factorization method. Simple factorization method. As in you factorize simply. So what is common to the 2 terms is x. Bring it out. That x used to divide x squared, you have x back. Use the x to divide minus 2x, you have minus 2 back. Equals 0. In quadratic equation, we get 2 answers because of one fact. The fact is, anytime 2 things multiply themselves together and your result is 0, then we conclude that either of them is 0. You know, before you can have the product of 2 values to give you 0, that means one of those 2 items is 0. It is when you have either A being equal to 0 or B being equal to 0, that is when their product can be 0. You know, 7 times 0 is what? 0. 5 times 0 is 0. You cannot have 5 times 3 to be equal to 0. It is when one of the 2 items is equal to 0, that is when their product can be 0. So whenever you see 2 things multiplying each other and the result is given to be 0, then you will say this x times this bracket gives us 0. It's either this x is equal to 0 or the bracket x minus 2 is equal to 0. That's going to be your judgment in quadratic equation. And if x is equal to 0, that's the end of that. Then this is a simple linear equation. Finish it. You have x equals 2. Collect the like terms. You take this minus 2 to the other side, which makes it become positive 2. So that is why it is. You say, therefore, x is equal to 0 or 2. So 0 and 2 are the roots of the quadratic equation. X squared minus 2x equals 0. Example 2. Find the roots of x squared equals x. When you see something like this, bring them together to one side. So you have x squared. This positive x on this side, bring it to the other side, making it to become minus x equals 0. Since nothing is left there, so 0 is there. How do we solve this? Factorize. X is the common factor there. Bring it out. Use x to divide x squared, you have x left. Use this x to divide minus x, it gives you minus 1. This is it. Minus x divided by x. This cut this. The coefficient of this x is minus 1, invisible, and that is what is left. So, equals 0. It's either this x is equal to 0 or the bracket x minus 1 is equal to 0. So x is equal to 1. Therefore, x equals 0 or 1. 0 and 1 are the roots of this quadratic equation. X squared equals x. That is it. Let's move to example 3.